Welcome back to the series of number system and conversion. This video focuses on hexadecimal to decimal conversion, and we will focus on two methods regarding this conversion. So what is given is hexadecimal number, and what output you will get? We want the decimal equivalent of that particular hexadecimal number. So let's get started. Now there are two methods. The first method, let's quickly go through the steps before we start applying this method. It says multiply decimal value of each hexadigit by its position weight, that is power of 16. Then add the sum of these products. So if you see here, this is step 1 and this is step 2, and here multiplication operation is happening, here addition operation is happening, and what you are multiplying it, you are multiplying it with some power of 16, but because your number is made up of certain hexa digits, so you have to find the decimal value of each hexa digit and then you will multiply it with the power of 16. So we will just understand this point in a minute, but then you have to add the sum of these products. So second part is easy, only thing you have to understand this portion. And before I discuss this method in detail, let's quickly see what method 2 tells me. It says hexa to binary to decimal. That means you are given a hexa number. Find out its binary equivalent first. And then you find the decimal equivalent of that binary number. And this decimal equivalent will be equal to the decimal equivalent of this hexa number. So this is two-step process. One is you must be familiar with hexa to binary conversion, and then you must know how to convert any given binary number to decimal number. The most commonly used method is method 1. So first we will focus on this method. What all additional details I need to know for this method? Let's see. Decimal number system is base 10 number system and it has values from 0 to 9. Hexadecimal number system is base 16 and it has values from 0 to 9 and A to F. So it has got 16 total characters. So 0, 1, 2, 3, 4, 5, 6, 9. Then we say A, B, C, D, E, F. So this is the sequence of our hex digits. But our rule said that when you have to multiply it, you have to multiply decimal value of each hexadigit. So we must know the decimal equivalent of each of this hexadigit, right? So that comes out to be 0 is equivalent to 0 in decimal. So remember that for the digits up till 9, the hexa and decimal equivalent are same. So it is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. But for these 6 alphabetic characters, we have to be careful regarding these alphabets when we are multiplying them with the powers of 16. So what is the decimal equivalent of A, B, C, D, E, and F? Very easy to remember. After 9 in decimal comes 10. So this will go in this sequence, right? So if I say F in hexa, that is equivalent to 15 in decimal. So if my number has F, and I need to it for multiplication purpose, I'll be using this corresponding decimal value. Now, you have to multiply this decimal equivalent with what? With the power of 16. So this hexa number is basically what? Weighted number system. So if I have this number F1, F, so this is fractional part and this is whole number part and this is our hexadecimal point. So we the weight of, see, this is also F, this is also F, but the weight of each digit or the magnitude of each digit will depend upon its position within the given number, and that is the weight of that digit. So since it is base 16 number system, so weights are the powers of 16. For the whole number part, we write positive powers starting from 0, then 16 to the power of 1, 16 to the power of 2, and these weights are increasing. For the fractional portion, they are again powers of 16, but they are negative powers starting from -1, right? If you look from this point onward, this is a mixed number. So this 3 is LSD and f is, in this case, is most significant digit. So if you start looking from this point and you move towards a more significant digit, you will find that our weights are increasing: -2, -1, 0, 1 and 2. But if you directly write weight from this point onward, you may end up with a wrong sequence, especially if your starting power gets wrong. So it's better, safe method is write all the powers separately for the whole number and separately for the fractional part, especially if it is a mixed number. So quick recap for method 1. Now, what are these values? Suppose if I have to multiply any hexadigit with 16 to the power of 5, then it is this value with which we will multiply. So these are the powers and this is what they multiply to. Right? 16 into 16 is 256. And these are our weighted system. So let's get started with the examples. These examples are a mix of uh, whole numbers, uh, whole number with fractional part, as well as having both the alphabets and the digits. So our first number is 10. This is a hexa number and I want to find out its decimal equivalent. So just for curiosity purpose, let me check out in my calculator what answer I will get if I directly check in my calculator. So I've chosen hexa over here and I write 10 and this is the answer which I expect, that is 16 in decimal. Let's see, we will perform a calculations. So it has got two digits, 1 and 0, and the decimal equivalent of 1 is 1 and 0 is 0. What are its positions? Because it's a whole number, so this is 16 to the power of 0 and this is 16 to the power of 1. So this gets 1 into 16 plus 0 into 16 and write down the powers. Solve them. 1 into 16 to the power of 1 is 16 and 0 into 16 to the power of 0 is 1. So this gets down to 0, 16. So this is the answer that we get in decimal. Double F. Second example. So there are two digits FF. The decimal equivalent of F is 15. So what are their positions? Weights are 16 to the power of 0 and 16 to the power of 1. So we will multiply that F, its decimal equivalent, with the powers of 16. So this becomes 15 into 16 plus 15 into 1. Anything to the raised to the power of 0 is 1. So this becomes 15 and you have to add up all these things. So this becomes 240 and this becomes 255. For this longer calculation, you can use manual method or you can use your calculator also, depending upon what is available. 3a. Now this has got both the alphabets as well as the digits. So 3 and a. What is decimal equivalent of a? 10. What is decimal equivalent of 3? 3. What is the power of a? 16 to the power of 0. And what is the position of 3 digit? That is 16 to the power of 1. So 3 into 16 and 10 into 16. So I won't write a over here. Naturally, you can't multiply a with 16. That is why that rule says that if it for every hexa digit, you have to write the corresponding um, decimal value. So we have to add them. These are our powers. So this becomes 3 into 16, 10 into 1, 48 plus 10. So this is the answer in decimal. So we have just attempted two examples. So this was the answer, our first answer for that value 10, 10 in hexa. FF got down to 255 and 3 is equivalent to 58. If you want to cross check, we will just calculate, we'll just check one value over here, 3a. So 3 and a. So you have to select the hexa part, 3a. So let me clear this out, 3a. So see, it is giving me 58. Decimal equivalent is 58. Now let's take a slightly longer example. It's a fraction number. So I've done some rough work already over here. This will be our answer. Let's check out. So there are two digits coming up over here, 1 and 6. Their decimal equivalent is also 1 and 6. Now these two digits are our fractional whole number part, and this 1 and 6 are our fractional fraction part. So their weights will be -1 and -2. And the weight for the whole number will be 16 to the power of 0 and 16 to the power of 1. So you can say 1 into 16 to the power of 1 plus 1 into 16 to the power of 0. One thing you have to take care that when you're writing those numbers, be careful, right? If you write any wrong number, like it's 1 and you write 3 in place of this, or in case instead of 6 you write 1, then the answer will come wrong. Right? So this becomes 1 into 16. Let me come up with this. 1 into 16 to the power of 1 plus 6 into 16, sorry, 6 into 1 upon 16 to the power of 2. So this becomes 1 into 16 plus 1 into 1, and this becomes 1 by 16 plus 6 by 256. So here the decimal portion calculation, whole number portion calculation is slightly easy. So that becomes 16 plus 1, right? So that will give me 17. Now what about that fractional portion? 1 by 16. So you can just use your calculator, or I have just done this rough work already over here. So that is 16 divided by 1, and this is how you calculate, and then you will get your this number, right? So what I'm getting over here in this case, 0.0625 plus 6 divided by 256. It will give me this long number. So that has been again already calculated for you. If you have calculator, you are allowed to use calculators. You can go for this. This is the number which you get, right? So this will be 0.0234375, right? Now 16 plus 1 was 17, and these fractional portions have been already added up over here, and this is the answer you will get for the fractional part. So that is 17.0859375, right? These two were added to give me that fractional portion, and this is whole is a decimal number, right? Now let us go with another example. It's purely made up of alphabets and also has a fractional portion. So it has got how many digits? A, B, C, and then dot, hexadecimal point D. So A, we have to find their decimal equivalent: 10, 11, 12, 13. What are their powers? 16 to the power of 0, 16 to the power of 1, 16 to the power of 2, and this is 16 to the power of -1. So 10 into 16 to the power of 2, then 11, then this 12, and then this. So this becomes 10 into 16 into 16 is 11 into 16, 12 into 1, plus this becomes 13 into 1 by 16 to the power of 1, that is 13 by 16. So this becomes 2560 plus 11 into 16 will give me 176 plus 12 into 1 is 12. Now 13 into 16, that is, this will become 13 divided by 16. So I've already done that little rough work already over here to save the time. So this is what you will get, 0.8125. So I have done this manual calculation, okay? And decimal portion is only one figure, so this will be our decimal portion, fractional portion, and just add up these three numbers, you will get 2478. So this is the answer, right? So abc.d is equivalent to 2478.8125. Then one last example that is made up of all big alphabets: F, A, C, E. Find out the decimal equivalent. F is 15, A is 10, C is A is 10, B is 11, C is 12, and F is 15, so E is 14. This position is 16 to the power of 0, 16 to the power of 1, 16 to the power of 2, and F lies at position 16 to the power of 3. So now you have to multiply these two digits. So 15 into 16 to the power of 3. So now I hope you understand this rule 1, which said that, let me go to that rule section where it said multiply the decimal value of each hexa digit by its position weight or the power of 16, and then you have to add the sum of these products, right? So I'll just quickly do this. Always try for the manual calculation procedure. So this become 15 into 16 into 16 into 16 thrice 4096, and this will be 10 into 256, plus this become 12 into 16, and this will become 14 into 1. Now remember, this is only a whole number, it has got no additional portion, so this will become 14, and this part will become 2560. 12 into 16 is 192, and 15 into 4096 is 61440. Add them up and you will get 64206 in decimal. Just quickly check in our calculator whether I get the same answer or not. So choose hexa and type the digit FACE and see you get to 64,206 in decimal. That is the equivalent, right? Now let's quickly go through that method 2. Method 2 said that you have to find first the binary equivalent. So for the binary equivalent, I must know first what is the hexa equivalent. So this is hexa number and this is a binary number. So every binary number is formed by 4-bit binary equivalent. 4-bit binary equivalent will give you that hexadecimal code. So if I say 0, in binary, we just write 0 as this, 1 as only 1. And if I have to write 2, I just write 1, 0. But when I have to show that this binary number is this is the binary equivalent given hexa number, then I have to put it 4 zeros over here. Whichever, just make 4 bits, sorry. Here because there was single one, so put 3 leading zeros to make it as a 4-bit number. So this is the chart, but we will quickly understand, like if F is coming in my number, then how to quickly get this number using sum of weight method. So let's solve 2-3 examples, and we will also see like what is the difference between the first method and the second method, which one is better. Let's see first this number 10. We had solved this using our first method, right? Now we will, this was method 1. Now we'll solve the same number using second method, right? Now see, we have to find their binary equivalent. We will go for this method, 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, because sometimes we may forget the binary equivalent. So this is the quick method. I've written these binary weights. Which numbers will give me? So there are 2 digits, 1 and 0. So you have to write 4-bit binary equivalent for each of the hexa digit. So that is what we do when we go from hexa to binary conversion. But now we have to go one step ahead because we have to convert that binary number into its hexa. So this is step 1, right? Which number will give me 1? Only this. Rest of the weights are 0. So this is the code for 1. Which number will give me 0? None of these weights add up to 0. So it will be all zeros. So 4 zeros, 4 bits, right? So combine this into a single binary number. You can omit these leading zeros, 1, and how many zeros this side? 4 zeros. Now you're getting to see the difference here. I had just to handle 2 digits while I was calculating using this power method, but now I have to handle here how many bits? 1, 2, 3, 4, 5. Okay, now you can write down their powers of it. So step 2, convert this binary number. I have to be more extra careful over here. I just can't omit out even a single bit. So write down the weights. Anything raised to the power of 0 multiplied by 0 will be 0. So this weights will get omitted and only weight left is 2 to the power of 4 is 16 and 16 into 1 will give me 16. So this is the answer. So if you see here, this answer is same. No in method 1 also and in method 2 also. But advantage is that when you're using this powers of 2, comparatively they are simple calculation as compared to the especially the bigger powers of 16, but here you have to handle a large binary string because you know that hexadecimal number is a compact representation of long binary strings. So if you convert this number into binary, one hexa digit will occupy how many bits? 4 bits. So if it is a hexa digits, that means you have to convert each hexa digit into its binary equivalent. So that will become 8 bits. If it is 3 hexa digits, that will become 4 into 3 is 12. If there are 4 hexa digits, then 4 into 4 3 the 12 3 into 4 is 12, 4 into 4 it will become 16 bits, so number of bits will increase. And if it's especially if it is just a combination of all zeros and ones, you will have to be extra careful over there. So this number was comparatively simpler. Answer will be same. Let us take this number ff. This was solved using method 1. Let us solve this method using method 2. F F. So like write down our weights 1 2 4 and 8. Now f in hexa is equivalent to 15 in decimal. So which weights will add up to give me 15? 8 plus 4 plus 2 plus 1 is equal to 15. So 8, 9, 10, 14 plus 1, 15. So we will put 1 under each of these weights. So this weight was 2 to the power of 0, 2 to the power 1, 2 to the power of 2 and 2 to the power of 3. So 4 ones. So one f gets translated into 4 bits. But there are 2 f's over here. So again for the same. So this is step 1 and this is the number we get. So while writing these one sequence, you have to just do one counting once. Omitting even a single one will give an error. And if it is a combination of zeros and one, then putting 0 in place of 1 or 1 in place of 0 will also give a wrong answer. So 1, 2, 3, 4, 5, 6, 7, 8. So remember, using this method, I had to handle just 2 digits, but here I have to handle now 8 bits. So let's see step 2. What you are going to do, you write all the ones, 4 ones, just write in group of 4s, so that will, you won't commit the mistake in that sense. Write down all the weights. Then this becomes 16, this weight is 32, this weight is 64, and this is 128, right? These are the weights, but over all bits are 1, so all will be taken into consideration. So 128 plus 64 plus 32 plus 16, then 8 plus 4 plus 2 plus 1. Add them up, you will get the same answer, 255. So just see the difference between the two, right? Here just two calculations were required, one this set and another this set. But here I had to go for a long sequence of binary numbers, additions. No doubt power of 2, the calculation is slightly simpler, especially when powers of 16 become very high, number gets very big. But you have to handle lesser number of digits in hexa, and when you go for bind this method, you will have to work with more number of deal with more number of bits. So we can remember this method, especially if you are asked to perform this conversion using this method, then you can use this method, or you are asked to specifically that perform using both methods, you can do that. But if method is not asked, then generally this is the preferred method, right? So I'll just give you one query over here. Suppose I have triple F. Let me write this number. Suppose I have, this was double F. We have done this. If I write triple F, then this will get translated into 1111, 1111, and how many bits? 4 to the 8, 12 bits. So our weights will increase. And if it is 4f, so 4 into 4 is 16. So count the number of ones, 4 to the 8, 4 to the 12, 4 for the 16 bits. And if this bits combination becomes a combination of zeros and ones, long binary string, then generally avoid this method. Because if it is a larger hexadigit, naturally binary string will become more long, and then it may become slightly confusing, right? You have to be careful where you are having 0 and where you are having 1. But anyway, these are the two methods which are offered, and you can use any of these methods. So thank you for viewing, and you can subscribe, like, and share if you have understood the topic. And I'll meet you in my next video on this in this series.